Hello everyone, welcome back. This is the second section of Cambridge exam, mechanics to be precise, 9709 paper 4 variance 2, May June 2023. If you have subscribed to my channel, you'll have seen the first part. This is the last part of this particular variance. And the question there is just one question. Two particles. We have two particles labeled P and Q. The one of P has a mass of 2 kg, is resting on the inclined plane. And the one of Q is 0.25 kg, is hanging freely. As you can see, the angle on the inclined plane is 30 degrees. And the question gave us two sections on the inclined path. Point AB, if you do the question properly, point AB is the rough part, point BC is the smooth part. And particle P is released from rest at A, which means P is initially at rest before they release it. And according to the question, once they release particle P, it will accelerate in this direction, while the one hanging freely will accelerate upward. But the question now asks us that we should find the acceleration between the rough part A and B. To find the acceleration between the rough part A and B. Now I need to draw a skeletal diagram for the inclined plane. Okay, but our main concern is the rough part A and B. This is 30 degrees. Now there's a part, this is a pulley. This is mass, this is the particle P. The one is hanging freely. The one hanging freely is called Q, and the mass of the one hanging freely is 0.25. So the weight will be 0.25 g. That will be the weight. Look at the force in the wire is called tension. Tension holding Q. T. Tension is always stretching out. And tension. The tension. Okay, wait. Let me draw P so you can see the tension properly. Okay, this is a pulley. This is Q. Sorry, this is P. So the wire holding P to the pulley, it has the tension always stretching out. So let's resolve the forces. If you remember, I said the acceleration is in this direction. So this is the weight of P. The weight of P is mg. That will be 2g. Since it is inclined at 30 degrees, you have to resolve it. When you resolve it vertically down the incline, you're going to have mg cos theta. Down the inclined plane, when you resolve it, you're going to have mg. This side is mg sin theta, and this side is always parallel to this side. They're always parallel. So here will be mg sine theta. And we are talking, and the question precisely said between A and B. Between A and B. Between A and B is rough. So there will be frictional force in opposite direction. There will be frictional force in opposite direction of mg sine theta. Don't forget, you are dealing, the section of the plane I'm talking about, dealing with now, is between A and B. Maybe, let me use another color to identify the A and B. Okay, maybe here is A. Let me put here as A. So this is what is happening between A and B. Let me put B here. Let me go back to my black. Okay, don't forget, after resolving, the normal reaction is up like this. Now we are going to deal with two sections along the inclined plane and the one hanging freely. If you are resolving along the inclined plane, according to the question, line of greatest slope, we have a force down. The force down is mg sine theta, this, and the one up along that plane, we have frictional force going against mg sine theta, and we have the tension force in the wire going against mg sine theta. So the forces acting on P are three forces: one down, two upward. So we need to find resultant force. Resultant force will be mg. The mass is for P. Mg. The resultant force will be mg sine theta. Like I said, that's mass of P because P is the one along that plane. Mg sine theta minus frictional force minus tension. According to Newton's second law, force is ma. Don't forget that the mass along the plane is mass of P, ma, equal to mp mg sine theta. Frictional force is coefficient of friction times normal reaction minus tension. So we have mpa equal mg sine theta. Normal reaction in this situation is always equal to mg cos theta. After resolving, normal reaction is always, it's upward, the other one is downward. It's like upward force is equal to downward force, mg cos theta, that's normal reaction, minus tension. Don't forget the mass we are involved here is P. So make T the subject of the formula. When you make T the subject of the formula, then you're going to have something like this: mpg sine theta minus coefficient of friction, mpg cos theta minus ma, equation 1. Now let me resolving along Q. That's the one hanging freely. Along Q, we have two forces acting on P: the tension force, which is always stretching out, and the weight downward. So since we have two forces, resultant force in this case will be tension minus weight. The weight is mq. The mass involved here is g. Rf, resultant force, will be ma, right? Equal to T minus mqg. Also make T the subject of the formula. T will be mqa plus mqg. equation 2. Now we have two equations, so equate both equations. So equate equation 1 and equation 2. Why are we equating them? Because they are both equal to tension. And make A the subject of formula because we are looking for a solution between A and B. Equation 1, that's MP G sine theta minus coefficient of friction mg minus ma equal to equation 2 mqa plus mqg. Collect the like terms, bring the one with a together. At the end of the day, we have mpg sine theta minus coefficient of friction. Oh, this one is mpg cos theta minus mqg equal to mqa plus mpa. Let me correct this. I omitted something here. It's actually mu mpg cos theta. Okay. At the end of the day, let's make A the subject of formula. A will be G is common here. So what do you have here? MP sine theta minus mu MP cos theta minus MQ all over MQ plus MP. So this is the model for this kind of question. They might ask you to prove something like this. That's how I have to explain to you how it works. So let's substitute a value into this. G is 10, mass of P is 2, theta is 30, mu is 0.3, mass of P is 2, cos 30, MQ is 0.25 all over MP plus MQ. That's 0.25 plus 2. So insert this in your calculator. Your acceleration will be 1.024 meter per second square. Approximately, it can be 1.02. That's the acceleration between A and B. I believe you understand this. If you have any question, comment. Let me ask in the comment section. The second question, N. Find the speed at C. Okay, to find the speed at C, this is what I'm going to do. You know, we just find this acceleration between A and B now. Between A and B, we have the acceleration. But the question asked me to find the speed at C. To find the speed at C, I need the speed at B. So I can consider the two sections, B and C. We can only consider two sections at a time. So now, remember that at A, we want to go to that what I'm doing now. Remember that at A, the mass is held at rest. So the velocity is 0. I'm considering A to B now. I'm considering the section A to B. Velocity is 0. I don't know the velocity at B is unknown. But between that section, the acceleration between that section is 1.024 meter per second. And the distance between that section, if you check it, is 0.8 meter. So using V square equal to U square plus 2AS. So the final velocity, since it's from A to B, final is at B, that's VB squared. Initial is at A, which is 0. The acceleration between that section is 1.024 and the distance between that section is 0.8. So VB square equal, let me use my calc, 0.8 multiplied by 1.024 multiplied by 2. You're going to have 1.6384. So VB will be square root of 1.6384, which gives square root of 1.6384. So the velocity at that point at B is 1.28 meter per second. Now I have velocity at B. Now I can now get the velocity at C. So, which means to get velocity at C, I'll consider the two sections B and C. I need to draw another diagram considering just section B and C alone. I need the acceleration between, okay, this is it. Considering section B to C, I have the velocity at B now to be 1.28, but I don't have the velocity at C. It's unknown. The distance between that region, I think, is 1.2 meter, but the acceleration is unknown between that region. So to get the acceleration, I need to draw the diagram again. It's a skeletal diagram. I need to draw a skeletal diagram. This is 30 degrees. I'm considering just between B and C. Let's say here is C. Let's say here is C anyway. But the distance between them is 1.2. This is C. I'm considering between B and C. Remember the question said BC is a smooth section, right? And at this point here, we have a mass. The mass here, the mass is connected to the one hanging. So which means that W here is 0.25 G. This is Q. This is P, like I did. Tension stretched out. Tension stretched out. Remember, it's a smooth section, so there is no frictional force. The only force, after resolving, this is weight. When you resolve here, it's going to give you mg cos theta. This is weight, right? This one will give you mg sin theta, which is parallel to this place, like I said, mg sin theta, and here is normal reaction. It's still the same thing, but the difference is that there is no frictional force. So along the inclined plane, that's along P, the resultant force in this section, the resultant force, that's MPA, I don't want to waste time, equal to mg sin theta minus tension. So our tension in this case will be MPG sin theta minus MPA. Now I'm looking for the acceleration. Let me just get the value. My MP is 2, G is 10, sin 30 minus 2A. I don't know A. So in this case, my tension will be 2 times 10, 20. 20 sin 30 is 10. 10 minus 2A, equation 1. Now, along Q hanging freely, this equation 1 is along the plane. Now, along Q, we're going to have T minus 0.25 G equal to 0.25 A. In this case, T will be 0.25 A plus 0.25 G, which is 2.5. So equation 2. When you equate both of them, equation 1 and 2, I have 10 minus 2A equal 0.25A plus 2.5. So 10 minus, collect the like term. I'm minimizing my space. 10 minus 2.5, I have 7.5. 7.5 equal 2.25A. So in this section, between B and C, the acceleration is 7.5 divided by 2.25. Along that region, acceleration is 3.33 meter per second square. That's the acceleration in the smooth section. If you observe, is greater than the acceleration in the rough section. Now, we can now get the velocity at C. We are still considering BC. So velocity at C probably will be, it's BC region, VB square, VC square equal to VB, B is the initial, plus 2AS. So VC square, velocity at B, that's what we got before, that's 1.28. 1.28 square. Our acceleration 3.33. That section BC, the distance is 1.2. Let me check and confirm. Yeah, the distance is 1.2. So let's get this up. 1.28 square. We have, that's 1.6384 plus 2 times 3.33 multiplied by 1.2, 7.992. Add them together, plus 1.6384. So VC, now the square root of the addition, that's 9.6304. So square root of 9.6304, we have 3.1. So velocity at C is 3.1 meter per second. That's perfect. I have another method to solve this question, but I'll post it when I'm done. So if you have any question, on comment section. And the last question, find the time taken for the P to travel from A to C. Time taken for P to travel from A to C. From A to C, time taken. Okay. The last question. This is interesting. Find the time taken for P to travel from A to C. Time taken from A to C. We have two sections, A to B and A to C. So the time taken from A to C, that's TAC, will be the combination of the time for the two sections, AB plus AC. Now let's get the time for AB. So using B equal to U plus AT. For AB, B is the final velocity, A is the initial. We can now get the time. The final is 1.28. The initial is 0, is head at rest. The acceleration between that region is this, multiplied by time. At the end of the day, 1.28 divided by 1.024. So time taken between AB will be 1.25 seconds. Or using S equal to UT plus half AT square. It's still on this section AB. Initial velocity at that AB is 0. 0 times t is 0. Acceleration of that region is 1.024 t squared. Distance of that region is 0.8. So we have 0.8 equal half of 1.024 t squared. So if you cross multiply, 2 times 0.8 divided by 1.024 square root will give me t. Put in your calculator to give us 1.25 seconds. That's still for AB. For BC, still the same. Using the same formula, BC equal to UB plus AT. Velocity at C, this is it, 3.1. Velocity at B is 1.28. I don't have the acceleration. The acceleration at that region is 3.33 multiplied by t. So here we have 3.1 minus 1.28 divided by 3.33 will give us the time at that section. So 3.1 minus 1.28 divided by 3.33. So the time at that section will be faster because it's smooth, so we have a small time, 0.5465. Hence, time between A and C, add them together, that will be 1.25 plus 0.5465 plus 1.25. So time between AC we give 1.7965, approximately 1.80 seconds. Thank you. Please subscribe to my YouTube channel. There are more interesting content coming with different formula, different techniques. Please subscribe. If you've learned anything, share it to your friend so you can get immediate notification once I drop the next video. See you soon.